Welcome to Science Flow. Today, we are going to become rock scientists and food scientists at the same time. We will learn how 3 different types of rocks form, and then we will create edible models of them. Our big question is, how do different processes make different types of rocks? Would you ever eat a real rock? Of course not. But today, we will use food to model how rocks are made. Look closely at these rocks. What colors, layers, textures, or patterns do you notice? Do you think all rocks form in the same way? Pause and discuss. What do you notice? How are these rocks similar or different? Here is our science flow for today. First, we will observe real rocks and learn the 3 main rock types. Next, we will make predictions and create 3 edible rock models. Then, we will compare our results, explain the evidence, and finally taste our models. Remember our science flow: observe, model, compare, and explain. Our investigation question is, how do layering, heat, pressure, melting, and cooling change materials? Before we begin, make a prediction. What will happen when we stack and press ingredients? What will happen when we add heat and pressure? And what will happen when melted chocolate cools? Sentence frames. I think the layered ingredients will. I think heat and pressure will. I think melted chocolate will when it cools. Today, we are making scientific models. A model is not exactly the same as the real object, but it helps us understand an idea. Our food ingredients represent rock materials, and our cooking actions represent natural earth processes. Our edible rocks will form in minutes, but real rocks form through natural processes over much longer periods of time. There are 3 main types of rocks. Sedimentary rocks form when small pieces build up in layers and become compacted and cemented together. Metamorphic rocks form when an existing rock changes because of heat and pressure. Igneous rocks form when melted rock cools and becomes solid. Listen for the important processes: layering, pressure, melting, and cooling. Rocks can change from one type into another. Sediments can be compacted and cemented into sedimentary rock. Any rock can change into metamorphic rock when it experiences heat and pressure. If a rock melts, it becomes magma. When magma or lava cools and solidifies, it becomes igneous rock. This continuous process is called the rock cycle. Lead challenge. What must happen before an igneous rock can form? Let's learn our key vocabulary. A sediment is a small piece of rock. A layer is material placed above or below another material. To compact means to press materials closely together. To cement means to stick pieces together. Pressure is a pushing force. To melt means to change from solid to liquid. To solidify means to become solid again. Repeat together. Pressure compacts the layers. The melted material cools and solidifies. Look at all of our ingredients. Which ingredients could represent small sediments? Which ones could make visible layers? Which ingredient can melt? Which ingredients can be pressed and changed? Think like a scientist and explain why each ingredient matches a rock-forming process. Pause the video discussion time. Work with your team to sort the ingredients into 3 groups: sedimentary, metamorphic, and igneous. Speaking frame. I chose because it can. Sedimentary rock begins with weathering, when larger rocks break into smaller pieces. These pieces are called sediments. During deposition, the sediments settle in layers. As more layers build up, they become pressed together through compaction. Minerals or other materials then act like cement and hold the pieces together. Key idea: sedimentary rocks often have visible layers. Let's make our first edible rock model. Add 1 layer of cookie crumbs to your clear cup. Then add cereal pieces, sprinkles, or other small ingredients. Add a thin layer of frosting to act like natural cement. Repeat the layers and then gently press everything with your spoon. The pressure represents compaction. Pause the video, make it. Create at least 3 visible layers. Do not eat your model yet. We need to observe and record it first. Look through the side of your cup. How many layers can you see? Are all of the pieces the same size? What happened when you pressed the ingredients? The frosting acted like cement. The spoon pressure represented compaction. Complete the sentences. My sedimentary model has layers. The frosting acted like. Pressing the ingredients represented. Metamorphic rock begins as an existing rock. Deep inside Earth, heat can soften and change its minerals. Pressure squeezes and stretches its layers. The rock changes its shape, texture, or pattern, but it does not completely melt. The word metamorphic means changed form. Think about it. What might happen to rock layers when they are squeezed? Now let's make a metamorphic rock model. Stack 3 or 4 different colored fruit chews. Cover them with parchment paper. Warm them gently with your hands. Then press them firmly. Use a clean cup or rolling pin to flatten and stretch the layers. Fold the model once and press again. Do not melt it. Pause the video ad. Heat and pressure. Keep the candy inside the parchment paper. Press slowly and carefully. Open the parchment paper and look closely at your model. Did the colored layers bend, stretch, or form bands? Did the candy completely melt? Heat made the candy softer. Pressure changed its shape. This models how metamorphic rock changes without becoming magma. Complete the sentences. The heat made the candy. The pressure made the layers. My model changed, but it did not. Igneous rock begins with melted rock. Melted rock below Earth's surface is called magma. Melted rock at the surface is called lava. When magma or lava loses heat, it cools and solidifies. The solid material becomes igneous rock. Prediction question: what do you think will happen when melted chocolate loses heat? An adult will prepare the melted chocolate. Add a spoonful of melted chocolate to your cup or mold. Mix in puffed rice, cereal, or small cookie pieces to represent minerals. Stir gently. Then place the mixture on a cooling tray or in the refrigerator. As the chocolate cools, it will solidify. Pause the video, make and cool it. An adult must handle the warm bowl. Do not touch or taste the melted chocolate until your teacher says it is safe. Let's compare the chocolate before and after cooling. Before cooling, it was warm, soft, and easy to change. After cooling, it becomes harder and keeps its shape. This models how magma or lava cools and solidifies into igneous rock. Complete the sentences. Before cooling, the chocolate was. After cooling, it became. This represents magma or lava and. Now compare all 3 edible rock models. The sedimentary model was made by layering, cementing, and pressing. The metamorphic model changed through heat and pressure without melting. The igneous model was melted and then cooled until it became solid. Look for visible evidence in each model. Discussion questions: which model has clear layers? Which model has bent or stretched bands? Which model changed from soft or liquid to solid? Now it is time for the Rock Detective Challenge. Look at models A, B, and C without reading their names. Identify each rock type and explain your evidence. Do not just give an answer. Tell us what process or feature helped you decide. Pause the video team challenge. Speaking frames. Model A is rock because I can see, which is evidence of this model cannot be because. Before tasting, finish your observations and your science report. Think about which model looked most realistic. Think about which process caused the biggest change. Which model was easiest to identify? How is an edible model different from a real rock? Speaking frame. My favorite model was because. Now complete your exit ticket. Heat and pressure make metamorphic rock. Cooling melted rock makes igneous rock. Compacted and cemented layers make sedimentary rock. When all of your science work is finished, your teacher will tell you when it is time to taste. You rocked this science lab. Let's review one final time. Sedimentary rock forms when materials layer and press together. Metamorphic rock changes through heat and pressure. Igneous rock forms when melted material cools and becomes solid. Different processes make different rocks. Great work observing, modeling, comparing, and explaining today. Please like this video. Subscribe for more science flow lessons. Share your science learning. Keep exploring. Keep asking questions. I'll see you next time.